is everybody?
Well, a lot more went distance learning. Not a lot, but a good handful. So distance learners, as I backtrack here, just a plain sheet of white paper, Sam. It's on a Peyton's desk. Okay, so Schoology looks a little different. I took the slideshow off because we're going to be running off of a Google Doc. So distance learners who are new to distance learning, it won't really matter. It'll be the only thing you know. But the other ones who have been there for quite a while, you will be working off this document. I just leave it open all the time. We went to this last year, this format, because if you remember, Schoology was down a ton. Remember when you went distance learning at the beginning? Schoology was down like the whole first week or off and on. And so I immediately, because we didn't want to lose prep time, I immediately went to a Google Doc. And it's just easier for me to transfer files over and stuff this way, so I can just kind of copy paste. So it still kind of says what we're doing in class and what's for homework. Everything will be linked on here. You'll notice these green things are new. These are things that get collected, not daily anymore though. So anything with a number in green will get collected. Your first collection is Thursday. Distance learners, obviously, the people in class are gonna keep it in a binder, and I'm just gonna collect it while they're watching these notes on Thursday and give it right back to them. You guys are going to have to post as a PDF. So you're not going to be turning something in daily anymore. It's just going to be kind of as we go. I'll collect the binders every once in a while. There'll be a lot more things for test points. So for some of you, that's really good if you need to build your grade up, because it's not based on how well you do, it's how complete you do it. So I want you finding what you did wrong, correcting stuff. So grades can go up quite a lot unless you're somebody who doesn't keep up with the homework, then they go down. But it won't be quite as, like today I think we'll finish in class. So today we're just going to do a really short 10 to 15 minute limits review, but you should write the notes down. That's number 1 that goes in your binder. And then you're going to do a Google form 20 multiple choice questions on limits and continuity. If you finish in class, great. All right, but you'll notice number 2 is your work for the multiple choice. The first unit had some graphical stuff in there, so I know there's some you can't show work. So like if number 3 was reading a graph, just write, I read the graph or something. Does that make any questions from you guys in class? All right, so on the blank sheet of paper, and those of you at home, you should get a blank sheet of paper. We're just going to go all the way back. Our AP test is going to come up fast and furious. You'll do great on it, I can tell already just based on some stuff, but it does require some review, so we're going to go all the way back. My review is purposely very random. So you're going to be going, what's going on here? Like, we did multiple choice on continuity one day, and then an FRQ on graph analysis, and then a quizzes, and then it's going to seem really random on purpose, because those of you who did the practice test, did you notice every question kind of like, whoa, what's this now? I'm integrating, and then I'm taking a limit, then I'm doing a derivative, and then it's a related rate. And so that's how we review for it, so you don't get kind of, so today is limits and continuity. Actually tomorrow is as well, but then every once in a while I just throw something weird at you. All right, so first of all, right on the top of your paper, number 1, whoops, it's not activated for some reason. Hooking everything up after break is kind of an issue, I think. Still not activated, so let's go here and try this. Screen capture, screen share, smart settings maybe? Sorry guys at home, I'm having a technology issue here, but I should be able to, smart ink. I want it on, okay, and it's still not going. Anyone in the peanut gallery out here want to help me out? Anything you can see I might need to click on? I don't know, let's try that. Yes! All right, there we go, now we're ready. Sorry, I unhooked everything when I brought it home for break. All right, so write number 1 on the top here, and write limits and continuity. It's kind of old school notes. Sometimes they're on handouts, sometimes not. I just want to hit a few things. We were good at limits and continuity, so we're going to start off with limits. The very first thing is just the definition of a limit. When does a limit exist? Who remembers that? A limit exists only when what happens? When you left and approaches right, you end up at the same spot. Yeah, so we say a limit exists. So sometimes you'll be putting does not exist. If you come in from the left of a constant, and let's call that constant A. Sometimes we call it C, but I don't like you to get dependent upon variables. So if we come in from the left, we must equal what we get when we come in from the right. Remember what I said the way back in September? I said the restaurant doesn't need to be there, though. You just need to be there. So what that means is there very well could be an open dot. But as long as both roads lead to the same place, you have a limit there. You don't have continuity right there, but you have a limit. All right? So that's our definition of a limit. Then when we evaluate limits, so evaluate. All right, so just really quickly, what's the very first thing I told you to do if x was approaching c? From either the left or right or both directions. When you evaluate a limit, what's the very first thing you do? Plug it in. Yes, and a lot of times you get an answer, so I don't like to disregard that. I shouldn't say a lot of times, but when you do, you're like, sweet. I arrived at 0, or I arrived at pi, or I arrived at 2. What was the issue, though? When you arrive at what? What caused you to go, oh, crap? 0 over 0 was our issue, okay? So let's write if number, right? And that's great. And I mean, these notes are just a very broad overview, because that's all you should need. All right. But we said, oh no, if you get 0 over 0. So let's talk about that. It doesn't mean your answer is 0. It doesn't mean it's 1. It doesn't mean it's undefined. It means it needs more work. What was some of the work? Let's indent here. What was one thing we tried to do? Factor was the big one. If it was a polynomial over a polynomial, we would try to factor, and we'd hope things canceled. And then I want you to point, because that led us to continuity. Let's see if you remember this. If you got 0 over 0, and stuff factored and canceled, what was there on the graph? There. A hole in the graph. Exactly. If what was on the top canceled with what was on the bottom, we have what's called a hole in the graph. It's also called a removable discontinuity. Okay, because you can remove it by plugging it in. There's still a limit there. It's just we have an issue. Now, if stuff didn't factor and cancel, it depends. We went through in chapter 1, we did a whole bunch of things like conjugates and a bunch of trig stuff. But later, after we learned derivatives, there was a big hitter that was really helpful. Do you remember what it was? It allowed us to take the derivative of the top over the derivative of the bottom and replug. And that took care of a lot of the messiness. L'Hopital's rule. Yeah, so I suggest L'Hopital's if things don't factor and cancel. Good job, you guys in class. I like it when we're answering questions from all the way back in September when we're sitting here in April. That's pretty impressive. All right, a lot of times there's crickets, which is what I expect. It's great. That's why we do this. If everybody remembered all of it, I'd be wasting your time. But L'Hopital's is awesome. Remember what you do, not just again abbreviating, but you do the derivative of the top over the derivative of the bottom, and then you replug it in. If you get 0 over 0 again, you L'Hopital again, right? So L'Hopital's is great. L'Hopital's also works for infinity over infinity as well. So it combats both of those indeterminate forms. I'm going to actually write also, so you don't think that that's what I mean, that fraction. It also works for that. So I'm going to repeat. When we approach a constant, we plug it in, we hope we get something, right? Even if it's a piecewise, you hope when you plug it in the top piece and the bottom piece, you're at the same spot. But if you're not, you have a discontinuity. If that doesn't work and we get 0 over 0, we try, if it's polynomials, to factor and cancel and all that good stuff. So that's our first part about limits, all right? Oh, that's weird. I was trying to erase. Okay. Well, good thing I have prep next so I don't get too worked up, but just monitor and adjust. All right, so anyway, let's move on here. What other thing was I going to tell you guys about? It's on the limits. Oh, okay. Limits as we approach infinity of some function. I'm just going to call it f of x. A limit as we approach infinity. I want you to think about what that is. Watch me draw it graphically. Don't you do it. Are you ready? So x is approaching infinity, right? X is approaching infinity, and I'm getting a limit for my y value. What's another name for a limit as you approach infinity? A what? Asymptote. What kind? Horizontal. Yeah, because f of x is y, and if we're getting a limit, we've got a horizontal asymptote. These are also horizontal asymptotes. So if they ask you what the horizontal asymptotes are, you send x to the infinities. Okay? So it's not only positive infinity, it's negative infinity. We had rules for that were very, very, very helpful. So again, I'm going to have you indent. Maybe this. Oh, that's still activating. I'm going to use my manual eraser here. This ought to do it. Yep. Okay. Sorry about that. All right, so indent again. And what we're going to do is talk about those different forms that we get as x approaches infinity. All right, so let's indent again on wherever you were there. And we were approaching infinity. Remember what happens. There's three cases when you approach infinity. All right? Your three cases are bing, bang, boom. They're from pre-calculus. Okay? Here they are just in generic polynomial terms. The powers are tied. What's my limit as I go to infinity of that? 1/3. We steal the coefficient, right? So I think instead of steal the coefficient, I think we'll go like that and say, oh, it's going to let everything else is kind of balanced out. I'll arrive at 1/3. That's its limit. That's the horizontal asymptote. Y equals 1/3. If I had x cubed on the top and 5x to the 4th on the bottom, regardless of what the other stuff is, as long as those are the highest powers, right? Then what's my limit as I approach infinity? 0. My horizontal asymptote is y equals 0. Are we good with that? And if you want to write y equals 0, or you can add whatever you want to your notes there for you. All right? The other case is if the top is heavier than the bottom. And this is polynomial over polynomial, but I'll extrapolate that to some other cases too. What was the horizontal asymptote or the limit as I go to infinity of situation number 3? By the way, I'm 2/3 of the way through chapter 1. So you get what's going on here. Do you remember what happened in case number 3? Case number 1, my limit's 1/3, y equals 1/3 my horizontal asymptote. And again, I'm approaching the infinities here. We already have that, I just erased it. Right here, 0. What was this? Do you remember? It means it's unbound. Okay, it means we're heading to infinity. All right, so this means the y values are unbound. Now, keep in mind, these are polynomial over polynomial, but if you have battling function families, there's one in your multiple choice that says, which of these limits go to 0? It's very obvious that this one does, but what if I do that? Think about it. As I approach infinity, right? I get infinity over infinity. Think about it, right? Where's there a heavier or more powerful function, on the top or the bottom? Bottom grows way faster. Or you could picture L'Hopital-ing it, and you can go 3x squared plus 2, 6x, right? 6, 0. And what's the bottom going to keep deriving as? E to the x, e to the x, e to the x. You're eventually going to get 0 over e to the x if you picture L'Hopitalling it a whole bunch of times consecutively. So this also, so don't remember, it's not just with polynomials, it's when function families battle out as well. For example, 3e to the x plus a bunch of stuff that's not as powerful over 2e to the x plus a bunch of stuff that's not as powerful. What do you think the limit as x approaches infinity of that guy is? 3/2. Exactly, and you can picture L'Hopitalling it, right? But we'd eventually get 3e to the x over 2e to the x, and these would cancel. So it kind of not only works, they usually give you polynomials, but if they don't, remember, it has to do with bigs and littles. All right, next, continuity. All right, so the definition of continuity has 3 parts. And let's say at x equals a. What has to happen for a function to be continuous at x equals 2? There's 3 parts to the definition of continuity. What must happen? Give me one thing. It must exist. Yeah, we can't have an open hole there. That gives us a closed dot so that we don't have the open, right? What else has to happen there? By there, I mean at x equals a. I shouldn't walk away from my smartboard when I'm recording. But what else has to happen? There's a big one. Yeah, we don't want to have what's called a jump discontinuity or non-removable discontinuity. So we don't want, what he's saying is we don't want that to happen. Because this we exist, but we definitely have a continuity issue. So the limit as x approaches a from the left of the function, or the limit has to exist is another way of stating this, but I like to write it out. I think it helps. Okay, but what else must happen to avoid this? Limits are the same and undefined there, but I still have a discontinuity. What has to happen to avoid this case right here? What do you think, Luke? Help him out, Sean. Help him out, Harrison.
Also around the mouse one sec.
Help him out, Percy.
Is it like f of a has to equal the limit?
Yeah, these two have to equal. Remember when you're checking it, you're going, okay, I got a 3, and I came in from the left and the right, and I got a 3, and both of them are 3. But if f of a was 4, and your limit was 3, you've got these guys meeting at 3 with a dot up at 4. Now we're nodding. That's exactly why I do this. So I'm going to repeat what he said. The limit as x approaches a from both directions has to actually equal f of a. All right. And remember, we have different kinds of continuity, but with piecewise, we just check. It's pretty easy. And our last item of the day, also in this section, was the IVT, or in this chapter. What did it, that's one chapter in 12 minutes. What do you think? They come back a little bit, though? What did the IVT stand for, by the way? Intermediate value theorem. At the beginning of the year, I said you're eventually going to have what we call 3 existence theorems. The IVT was the first one, then the MVT. We also had a really obscure one called the EVT, which rarely gets tested. But for the IVT, the reason it was in chapter 1 is because the only thing in the hypothesis is if f is continuous. So when you use the IVT, you have to make sure you have a continuous function. Let's talk about what the IVT guarantees. It guarantees, first of all, I'm going to do it in non-calculus terms, the existence, and I'm just going to put in parentheses, of, because they all guarantee their existence theorems. It'll say, does there exist a C such that, or does there exist a time such that, or does there exist a, usually it's T for time. Existence of what I call Y values. It has nothing to do with derivatives. That's going to be super important for you deciding between the IVT and the MVT on the AP test. Oh, it's an existence theorem. Which one is it? All right, IVT we learned right away, and it didn't require any derivatives. It just guarantees the existence of Y values, whether they're on a table or on a graph. If this is T, time, and this is the temperature in degrees Fahrenheit at any given time today. And temperature is continuous. I have to pass through 51 degrees to get from 50 to 52 degrees, right? It might be fast, but I have to do it. All right, so suppose this morning on my way to work, it was actually 48. Okay, and that was at what time this morning? I came, 6:30, but let's just say 7, right? We're supposed to have a high today. Isn't it supposed to hit 80 today?
Yeah.
All right, so there's supposed to be a high of 80. And I don't know what time that's going to occur, but usually it's late afternoon, so let's say 4 o'clock. So if this was hours, this would be hour 0 at 7, and 4 o'clock would be hour 9. So let's just do that. All right, and here's my graph. What the IVT says, as long as you don't lift your pencil, you have to pass through every Y value. So it would, the prompt would be, is there a time today where the temperature has to be 64 degrees? And you say yes, because the function's continuous, and f of 0 is 48, with f of 9 being 80, and 64 is between 48. Remember writing that out? It was kind of a pain to write out, but it just says every Y value has to get hit at least once. So on a table, and it doesn't matter that you have the whole format down, but let me show you what it looks like tabularly, and then I'll let you just go to work. Usually if it's on a table, this is T for time, right? And I'm going to split these. I know your notes seem a little scrappy, but they should. It's a whole chapter on very fast. Suppose this is measuring the velocity of Bryce's and Bryce's bike, whatever, okay? And let's suppose at time 0, he started at 0, right? And we charted his velocity. And let's suppose 2 minutes later, he was going 4 miles per hour. That's about right for a bike. No, that's a little slow. And then he got going a little bit and he went 6 miles per hour. That's actually a little bit more realistic. And then at 9, he went -2. What does that mean he did at 9? Let's say 9 minutes into his bike ride, what did he do? If his velocity was negative, he went backward very slowly. Let's say, I'm just making this up just for shits and giggles, but let's suppose he only went on a 10-minute bike ride because he's out of shape, right? And he went backwards at 4 miles per hour. All right. It might say a couple things. It might say, are you guaranteed a time where Bryce was going 5 miles per hour? And that's verifying the Y value. It has nothing to do with derivatives. So this is IVT. Am I guaranteed a time where Bryce was going 5 miles per hour? Yes or no? At least how many times? Twice. Exactly. You get it? Now, how would you write that? If you already know, don't write it down. If you don't know, we'll say that you would have had to been told that the velocity is continuous or differentiable, right? Because anything differentiable is also continuous. DC, Diet Coke. All right. Since velocity is continuous with V of 2 equaling 4, right? You got to spot where you're spotting it on the table. You have to explain it. Since velocity is continuous with V of 2 equaling 4 and V of 4 equaling 6 and 5 is between 4 and 6. So you know what I mean? You'd have to write that out. You'd have to say, well, 5 is between those two. And since the function's continuous, the what? IVT. Actually, they say now you don't have to state the theorem. But I like it. Right? But the IVT guarantees. Now, there's also a time between which other two. Sometimes it's multiple choice. They'll say how many times, if any. 0, 1, 2, 3, or 4. And what did you guys tell me? 2. Sometimes you're just spotting stuff off the table. All right, we're done. You have a half an hour. And you have to take out your Chromebooks. And maybe, do you have room on that sheet of paper? Maybe just put number 2. I like them all on separate sheets. So if you have a blank backside, you can do that, but don't start it. You're going to label it number 2. I'm going to go back to So those of you at home, we are going to, for the rest of the hour, hopefully finish, because these are short. We're going to go to our Google Doc, which I would always keep open so that when you open your Chromebook, there's just a tab open. I should see lots of people on it all the time, even if you're not working. We're going to click on limits and continuity. We're going to hop onto that Google form. And again, you're going to show your work because that's number 2 in there. I do it on the Google form so I can see the most missed, because if you look at tomorrow's schedule, it says most missed. We're going to go over things that are missed the most. So like if you just read the graph, just state that. But go ahead, I think you're finished in the time given. All right? Were you able to access it okay? I think my link should all be golden. I'm going to stop recording this for DL here.